Let's continue our study of loops by choosing a cell phone contract again. This is our 5th iteration of this problem. Here's the problem statement. Suppose you want to compare the cost of several cell phone plans with ATV telecommunications. Each plan has the same basic design. A flat charge gives a fixed quota of minutes a month, and additional minutes are charged individually above that quota. Let's write a program that compares 5 plans. Now, we could start by copying and pasting our previous code 5 times. And in fact, that's the way a lot of people would try this at first. But the problem with that is the code gets extremely long and complicated. And if we find a subtle problem in one part, we're going to have to remember to change that problem 4 more times. People are notoriously horrible at doing this. So instead, we should look for a better control structure. In this case, the loop is a good control structure. We need to allow the user to enter the plan costs, and we need to pick the cheapest cost. So let's modify our code to use a loop. Now this is going to be a counting loop, and eventually we're going to have to run some predetermined tests. But we can work on those tests in a minute. Here's our code in Eclipse. I've taken our previous program, and I've pulled out only one of the examples. So let's read through the code and make sure we know what we need to change. We're creating a scanner here for the keyboard to read in input. That's not something we're going to need to change, and that doesn't need to be in the loop. Now, as far as the plan minutes and the monthly cost in pennies and the additional minutes, those are things we're going to have to read from the keyboard. So we'll erase the constants that we had stored there from our previous example. Similarly, our plan name will be a variable that will be read from the user. So, getting the input from the user of the number of minutes they talk, we need to consider whether that should be done inside the loop or outside of the loop. Well, if you think about it, because you want to make an honest comparison, you want this number to be the same every single time. And so that definitely needs to be outside of the loop. Here, on the other hand, is what needs to be inside the loop. Now notice we've got a bunch of red X's around. The reason is we've removed the initialization. So let's make a little comment. Read in variables from command line here, so we know we need to do that part. Now at this point, because we're going to put this in a loop, we're not referring just to the Super Saver plan. So I'm going to change the names of the variables here. I'm removing Super Saver from them. Consistently. Now you might think, well, you really don't have to do that. And that's true, you really don't have to do that. Because the variable name is the same and the computer doesn't care what the variable name is. But we always want to work towards keeping the code neat and organized. This is where our loop should occur. I'm going to start a counter, which will be started at 1, and then while count is less than or equal to 5, because we're repeating this 5 times. Everything from here, line 38, down to there is the body of the loop. If I highlight it and hit the tab key once, it will indent it all one position. As the logic starts getting more complicated, I add in a lot more comments so that I know where I am. So for example, I could put end if talk minutes here, else I could say end else from if talk minutes. Now it may look like I'm being a little silly with all these comments hanging around, but believe me, when we have to go back and read this code, you're going to be very glad to have them. The other reason that I like to put the comments at the end of the curly braces is it reminds me what I was thinking that curly brace ended. Sometimes these curly braces get out of sync while you're working on a program, and if you know what you intended to end it with, that helps you sort it out. In other words, this is one of those strategies where I'm taking a minute now to save hours later. Anti-bugging. The next thing we need to do is to read in our variables from the command line. So system out print line, enter the monthly cost, and then we'll see monthly cost in pennies equals keyboard dot next double, and then times 100. Now remember, keyboard next double, because we're reading in the monthly cost in dollars and need to change it to pennies. We're going to have to multiply by 100, but we're also going to have to round in order to get this correct. So we'll take the double, we'll multiply it by 100, we'll add 0.5 and truncate it to an integer. You've seen this strategy many times before. Now we'll do system out print line, enter the plan minutes. Now this is an int, so we'll do plan minutes equals keyboard dot next int, and then we'll say system out print line, enter the additional minute cost. So we'll say additional minutes pennies is keyboard dot next double times 100 plus 0.5, that's rounding again, and then we're going to truncate this to an int. Now I see one place where this code could be improved a little bit. Let's multiply by 100.0. Because next double is a double, this is going to be a double multiplication, and it just makes the communication a little bit clearer to show that that's a double clearly and that that's what our intention was. Another thing I'd like you to notice at this point is that our choice to call things like additional minutes in pennies and monthly cost in pennies has just paid us a big dividend. Because what's happened is that when we have a choice of entering data in dollars and pennies, we didn't forget to change our dollars into pennies and back. So these are where being careful with code really pays off. We do have quite a few lines of code here right in a row between line 38 and line 44. We could divide that up into 3 segments of code by adding a blank line, and that does make the code a little bit more readable. Now before we run things, we definitely want to step through our code one iteration at a time and make sure that we're doing the right things. So here's the total cost in pennies. Talk minutes greater than plan minutes. We take the monthly cost and we add on the additional minutes. That looks like it's still the same. Otherwise, if your plan minutes are smaller than your talk minutes, then you just get the monthly cost. Now notice that Eclipse is telling us that we've forgotten to enter the plan name, and we did forget that. Let's enter that. System out print line, enter your plan name, and we'll have plan name equals. Now we need to think carefully about this. Is a plan name going to be one word or multiple words? It could be multiple words like Super Saver and Big Talker were, so let's use next line. This also gets around the problem of having numbers entered after strings, where we have to read the new line separately. Now I carelessly put that line above our header comment, so I'll move the header comment up. Get rid of that extra line to keep things beautiful. And we now see that Eclipse is happy. The other thing we can see when we look at this is that we didn't handle our rounding case here. That's all right. We can leave it as it is right now. At this point, what we have in the program is an infinite loop, because notice we started the counter at 1, we checked to see if it's less than 5, but we never incremented it. Since count isn't involved in any of these calculations, it doesn't matter where we increment it. But by convention, you usually do it at the bottom of the loop. So let's go down here and increment. So we're going to keep track of the count. And that will be count equals count plus 1. So now we don't have an infinite loop, but we also don't have a comparison of the costs. So this is a little bit tricky. We might want to run the program once before we get started, just to make sure that our input is working correctly. It's always good to get input problems out of the way first. So let's run our program. Enter the number of minutes you want to talk. Well, maybe I want to talk 500 minutes. Enter your plan name. Uh-oh, did you see something go wrong there? Notice that the plan name skipped immediately beyond before I'd had a chance to do data entry. Well, guess what? That's that integer versus string problem that we've had trouble with before. So when we enter the number of minutes that we want to talk each month, we need to read in the new line after that. So let's go up here and fix that problem. So read in the new line at the end of the integer. We also need to remember to fix it in the if statement here. Otherwise, we'll just have this problem again when we hit this if statement. So we're reading in the new line at the end of the integer again. So this is why it's good to solve these problems and run the program, even though we haven't finished the code just yet. So if we're going to talk 500 minutes, now it's letting me enter my plan name. So Super Saver, the monthly cost, I think it was $19.99. Enter the plan minutes, 100 minutes. Enter the additional minute cost, 5 cents. Total cost for the Super Saver is $39.99. That sounds about right. But notice what happened here again. We went past enter your plan name. So this is that same new line mistake over and over. It's a very easy mistake to make. The way to fix it is after we read in our additional minute cost, we need to read in keyboard.nextLine to get rid of that new line character. We could do this in several places. For example, we could do this with monthly cost and plan minutes too. And in fact, I encourage you to do that. The cleaner you keep your I/O, the fewer problems you'll have with input that isn't working. Okay, so let's run again. So we're talking 500 minutes. We've got a Super Saver going on. It's at $19.99 for 100 minutes. 5 cents for an additional minute, and now it's asking for our plan name again. So we can see at this point that our input is working. Now what we haven't checked with that is that our loop is repeating 5 times. That's something we might want to check later. In fact, we'll need to check later. What we need to do next is to figure out how to keep track of the least expensive plan. So we've got a couple of things we're going to have to store. We're going to have to store the cost of the least expensive plan, and we're also going to have to store the name of the least expensive plan. The reason we need to do that is so we can show it to the user at the end. So before the loop, we'll have smallest cost plan, and now we need to think about how to initialize that. There are lots of different possibilities that you could use. One possibility is to set it to a gigantic number, and then it will be brought down with the first one. We could also set it to the cost of the first plan, but then we'd have to do it a little bit later in the code. So what we might want to do is to think of what the largest number is. That gets to be a little hard. One thing we could guess is that nobody's going to pay more than $1 million for cell phone coverage in a month. That's probably going to be okay for people. So that would be an arbitrary big number. Those things can cause trouble sometimes. There are other solutions to this problem, but this is one way to work with it. And let's call cheapest plan name and that one I'm going to set to the empty string. So there is a string there, it's just the cheapest one. We go through all this entering the data and then calculating the total cost. What we need to do now is to figure out if total cost in pennies is less than the name of our variable up there, which was smallest plan cost, well, if it is in fact lowest, then the smallest plan cost has to equal total cost in pennies. And of course, we need to change that to a capital C so that it matches the variable name. And we had cheapest plan name so the cheapest plan name is going to equal plan name, the one we read in. You'll notice that we've got some problems in Eclipse. It says smallest plan cost cannot be resolved to a variable. So let's go and take a look at what we did. Well, the name of our variable was actually smallest cost plan, not smallest plan cost. So we have to change to the variable name that's actually there. And of course, we'll have to do the same thing here. Now, when we get out of the while loop, that's when we need to tell the user which one was the cheapest. So system out print line, the cheapest plan was, and then cheapest plan name, and system out print line. People are always going to want to know the cheapest cost. So we definitely want to print that out. So we're going to have smallest cost plan. Now, one thing we did poorly with this is we did not point out that this is in pennies, which means at this point we might forget to divide by 100. Luckily, I remembered it, so we can divide by 100, so we get it back in dollars. And remember 100.0 to make it a double. But I think it's better to fix that. So we will add the word pennies onto all of the variable names, including the declaration at the top. That way we know what unit we're working in. And of course, we then have to modify the output at the bottom. Okay, so we're ready to run our program. But we've got a problem now because we need some test data. In order to run our program intelligently, we better create some test data. We need to create data where we know our result is correct. So we want to create fake data with a known answer. So if you look at what I've done in the table, basically the monthly cost is going up $5 a month for each plan. You're only getting one more minute, and the additional cost per minute is going up. So this means that plan number 1 is going to be our cheapest cost. That way it's easy without having to do a whole bunch of math, not that I'm opposed to doing math, to figure out which the lowest cost plan should be. So let's go and now run our data. Now I've actually taken this data and I've put it in as a separate file called test data. This is a good thing to do, to keep track of what your test data was. In fact, we could actually improve our documentation here by pointing out that plan 1 is the cheapest. Okay, so here we go, getting ready to run our program. So I'm going to talk 500 minutes. The plan name will be Plan 1. Enter the monthly cost, $9.99. The plan minutes, 100. The additional minute cost, 0.5, $29.99. That sounds reasonable. Enter your plan number, Plan 2. Monthly cost, $14.99. Plan minutes, 101. Additional minute cost, 7 cents. Total cost for Plan 2, notice it's going up, so that's good. Now we're at Plan 3. The monthly cost, $19.99. Plan minutes was 102. Additional minutes are 10 cents. Notice the cost is going up, that's good. Plan 4. Enter the monthly cost, $24.99. Enter the plan minutes, 103. Additional minutes will be 15 cents. Cost is going up further. Plan name, Plan 5. Monthly cost, $29.99. 104 minutes. And additional minutes cost 20 cents. The cheapest plan was Plan 1, and the cheapest cost was $29.99. Well, that's wonderful. That means our program is working at this point. Now, running it once like that did show that our loop repeated 5 times like it was supposed to, but it hasn't really checked all the cases very carefully. If I were going to deliver this code commercially, I would repeat the test, putting Plan 1 in the 2nd, 3rd, 4th, and most importantly, the 5th position, to make sure that data in any position can be the cheapest plan. And we, of course, could run the program more times. Now, we do have a remaining shortcoming with this program, and that's that requiring exactly 5 plans is weird. Let the user tell you when they're through. Now, the way we do this in a program is using a sentinel. So that has to be data that's legal to input, but doesn't make sense as data. So in this case, -1 is a good choice, because no cell phone company is charging negative money for a cell phone plan. The programming technique you need to use to make this work is called a priming read. So what you do is you read the data before the loop, and then you read it again at the end of the loop. So the data is read before the while loop starts, and then read again at the end of the while loop in preparation for the next trip through. Let's go back to the code. We're still going to have a while loop, but it's going to have the data done a little bit differently. The first thing we're going to need to do is take all of our data here, copy it, and move it before the loop. We're going to get rid of our counter because there's no other reason to have it other than just to repeat the loop 5 times. And now we're going to take our data input and put it at the bottom of the loop. We're also going to get rid of our increment down here. Now we have to think about how to put our sentinel in. Now, it would be nice for the user to be able to enter -1 right here. In this case, they're entering it with the plan name, so we might want to choose a different sentinel than -1. For example, we could say, or end to get the results. Then we're going to have to put a conditional here. If plan name dot equals to end, which I forgot to put the double quotes around, even though I knew it was a string. So only if the user doesn't enter end do we want to do that. Now I actually have the logic reversed at this point, because when they're not entering end is when we want to get the rest of it. Now this is an interesting problem about what to do with the loop. So we could say, while plan name dot equals end, this should be not equal, so put an exclamation point in front of it. So if it's not equal to end, then we go into the loop. And we'll have to put the same test down here. So enter the plan name, and if not plan name dot equals the string end. All of this stuff then will be indented. So remember, you highlight it first and then indent. Now we need to go back and put in some comments here. If not, plan name equals end. So let's see, we've got 1, 2, 3 left parentheses and only 2 right. So that's made Eclipse happy now. Let's see if we made that mistake up at the top. If not plan name equals end. Now that's interesting. That one only has 2 left parentheses and 2 right. So we might want to go and take another look at that one at the bottom and see if we did something wrong. We put in an extra set of parentheses that isn't necessary. Now those parentheses aren't necessarily harmful, but it's prettier without them, so let's not have them. There's the end of our while loop. Now we can run our same test data over. The difference here will be that we're going to stop after maybe 1 data is entered, 2 data are entered, 3 data are entered, to make sure that the priming reads are working correctly. Now I'm going to pull up the test data again because it was awfully convenient to have that available to look at while we were programming. Here we go. Enter the number of minutes you talk a month, 500. Enter a plan name, so I'm going to say plan 1. Enter the monthly cost, that's $9.99. Enter the plan minutes, which is 100 minutes. Enter the cost of additional minutes, which is 5. Now, one thing you'll notice is I forgot to tell the user to enter end here. That's a mistake that we're going to need to fix. But let's first see, enter the monthly cost. So it looks like that isn't working correctly anyways. It went and read it again. So we've got another problem to fix in addition to the problem with our prompt. There's no reason to go any further testing when that's wrong. So here's the prompt that needed to be fixed. Enter your plan name, which was or end to exit the program. Okay, so now we need to think about why it didn't see the plan name not being equal to end. Well, yeah, I did enter end in all caps, so that isn't the problem. But on the other hand, we could make this program better by doing equals ignore case. And in fact, let's do that in the top. Now what equals ignore case means is that the computer is going to do what you probably want to do, and that's not pay attention to whether the user entered end in capital letters or not. Since we use that same equals statement 3 times, we're going to have to remember to change it 3 times. So if the plan name is not equal ignore case to end, then you go ahead and read the rest of the data. Well, let's see if we fix the prompt and see if making it ignore case makes things better too. Let's run our program again. Enter the number of minutes you talked, which was 500. 1999. Whoops, that's a funny plan name, but that's okay, it could be anyone. So the monthly cost will be $19.99. The plan minutes would be 100, 5 cents for each additional minute. Now that's interesting. It looks like our plan name didn't get fixed, so we need to think about why that might have happened. So enter your plan name, enter the monthly cost, and that isn't fixed either. So clearly something is still going wrong. Let's go back and look at our code again and see what might have happened. So here's enter the plan name or end to exit the program. There's what the problem is. Look what we did wrong. We forgot to remove the input statements we had previously when we copied and pasted them. Let's remove those, which also tends to make our code better. Now at this point, Eclipse is freaking out, so let's see what it's unhappy about. It says the local variable plan minutes may not have been initialized. In fact, it has been initialized, because we know the logic of this program means that if we didn't put an end, that we're entering that data again. But the problem is Eclipse doesn't know that. And so we're going to have to do something that's logically unnecessary just to keep Eclipse happy. What we're going to do is go back to where we declared variables and just put in fake data. So we'll put in zeros here. Now we know this is silly. But unfortunately, this is what's necessary to keep Eclipse happy. And we should probably do the same with the plan name. Now, because it's a string, we can't put in 0, so what I'll put in instead is something called the empty string. That is a string with no characters in it. And once again, it looks like Eclipse is happy. And so now we're ready to read our program. Notice that our program is getting long, and that's one of the reasons that we're having problems with things like leaving extra code lying around. So here we go running the program. So I'm going to talk 500 minutes. This is my Super Saver plan. Monthly cost $19.99 for 100 minutes with 5 cents per minute. Additional cost is $39.99. That looks good. So now let's see if we end the program correctly. Now first I picked end in all caps. The cheapest plan was the Super Saver at $39.99. That looks good. Let's run 2 cases now. Now I'm going to bring my test data back up so I can look at that while I'm running it. So we're going to talk 500 minutes. This time it'll be plan 1, $9.99 for 100 minutes, 5 cents for each additional minute. Now we're going to enter plan 2. Monthly cost $14.99. Plan minutes was 101. Additional minutes were 0.07. Notice the cost for plan 2 was going up. So now we're going to end the program. Now this time let's put a little end and a little d there to see if our ignore case is working or not. The cheapest plan was plan 1 at $29.99. And we could go on checking to see if 3, 4, and 5 plans would be tested. The other thing to remember is it might be a good idea to do them in the opposite order, to make sure we're not just returning the first plan and that in fact we're returning the cheapest one. You can test a lot on code. So we've modified our code to use a Sentinel control loop. We ran our predetermined test, and it did look like our code was working. So we could reconsider our test data and stop after 1, 2, and 3 and still rotate test data. Now, some special cases we want to think about. What if the first one's the cheapest? Well, that's actually one we've already tested. What if the last plan is the cheapest? That's definitely one you want to test with a loop, because if a loop gets off by 1, that's where that problem will show up. What if there's only one plan? We tested that one. What if there are no plans? That's a funny one to test in this case, because if there are no plans, our logic isn't going to work very well. So in this case, it probably doesn't make sense to look for that test. Remember, keep programming.